Okay, so in this lesson 11.1.3, we're going to specifically talk about how does the volume change. So it's all about ratios of similarity. So you should have gotten from 11.1.2 that just like the perimeter ratio is very similar, the area ratio is very similar. Now we know the volume ratio is also very similar. So if you get stuck at any time, you can pause the video and you can pull out your methods and meetings box, which is at in your homework, and you can kind of look at your areas of similarities, right? So if something is growing at a different ratio, we're going to see that in the volumes. So you can always refer back to this. All right. So today, what you're going to do is you're going to analyze and solve everyday problems that involve area and volume. And as you work, think about whether that the problem involves your volume or your area. Right? Think carefully about how your similar solids are also related. All right. So let's look at this first question. To honor Benjamin Franklin, designers will place a statue of him outside the entrance to the Liberty Bell exhibit hall in Philadelphia. The designers decided to place a smaller, similar version on a table inside the building. The dimensions of the real-sized statue will be 4 times those of the smaller statues. The planners expect to need about 1.5 pints of paint to coat that small statue. They also know that the small statue will weigh about 14 pounds. All right, so let's take a look at these two questions, shall we? All right, so the first one asks us, how many gallons of paint are needed to paint the life-sized statue? So I want you to pause this video and ask yourself, are we going to be talking about area or volume? And I want you to take an idea and a guess of what we're going to be using. So take a moment and pause the video. So hopefully you figured out that the gallons of paint needed is definitely going to be the area, right? Because you're not painting the inside of the statue, you are painting the outside of the statue. So that is your area. So if you look at your ratios and similarity, okay, all of our area ratios, so if we have 1 unit, my ratio is 3, instead of just multiplying it by 3, I'm going to multiply it by 3 squared, right? So we can think of it, R is the perimeter, this is your area, and that's going to be your volume. So if we know that, right, what we're going to do is we're going to take the amount of paint that's going to be needed, 1.5, and I'm going to multiply that by the ratio. So the ratio, if you read back up here, it says 4 times that. So that is our ratio. So I'm going to go ahead and I'm going to multiply 4 squared. So this will be 1.5 times 16. So go ahead and you can grab your calculator and do that. And you should get 24 pints of paint. So that's how much it's going to take to paint the real life statue of this. So now let's look at part B. If the small statue is made of the same material as the large one, how much will the life-size statue weigh? So again, pause the video, think to yourself, are we going to be talking about area this time, or are we going to be talking about volume? Hopefully you wrote down that we are talking about volume, right? The weight of something, right? How heavy something is, right? That is going to be volume. So again, if you look at your ratios of similarity, we are going to take how much our statue currently weighs, right? Which is 14 pounds. So I'm going to start off with 14, and I'm going to multiply it by my ratio. So my ratio again is 4 times as large. So I'm going to multiply it by 4 to the power of 3. So this will be 14 times 64. So again, grab a calculator, and you should get 896 pounds. So that's how much the new statue is going to be. So again, a little bit different than how much paint is going to be needed. All right. So let's take a look at this next question, right? The Blackbird Oil Company is considering the purchase of 20 new oil storage tanks. They can buy the jumbo storage tanks or standard models. So this means that they're either going to be 20 of the jumbo or 20 of the standard. So each standard model holds 12,000 gallons. Its dimensions are 4/5 the size of the similarly the shaped jumbo model. So let's take a look at our questions. All right, so let's look at question A. How much more storage capacity would the 20 jumbo models give to the Blackbird Oil over the standard models? So I think I might need a little bit more room than what I currently have. So I'm going to grab a sheet of paper. Okay. So move this over here. So our sheet of paper. So let's think about what I know. So I am given some information. 4/5 the size. So I know that I am going to be cubing that volume, right? Now I don't really know what the original volume is because I want to find what the jumbo tanker is, right? So since I don't know the jumbo tanker, I'm just going to call it X. But if I multiply 4/5 cubed by the jumbo tanker's weight, I know that the standard weight should be about 12,000, right? Because that was our information given to us right there. Okay, so I'm going to cube everything. So this will be 64 over 125. Again, X is equal to 12,000. And I'm going to go ahead and I'm going to multiply by the reciprocal to both sides. So the 125 cancels out. 64 and the 64 cancels out. So X is going to be 12,000 times 125 all over 64. So take a moment, grab a calculator, and calculate that up. And hopefully what you got was 23,435 gallons. Right? So that is so far part A. So if I go back to the question, how much more storage capacity would the jumbo models give over the standard? So now I got to figure out how much more. So we're actually not done solving this question. So I'm going to go back to this. So this is for the jumbo. So that way I know. So I'm going to go ahead and I'm going to take away from the jumbo. I'm going to take away how much the standard oil storage tank was. So again, your calculator, 23,437.5. I'm going to subtract 12,000 from that. So that total should be 11,437.5 more gallons. That is for each one. So that means in 20 gallons, if I multiply that number by 20, right? That means after 20 gallons, I should have about 228,750 more gallons, right? And there's two ways that we could have found that. I just went ahead and I multiplied the difference by 20. But what we could have done is we could have multiplied this number by 20, this number by 20, and subtracted them both, and we still would end up with 28,750. Right? So now we've officially answered question A. Right? So we're good on question A. So let's jump to B. So if a jumbo tank costs 50% more than standard tanks, which tank is better to buy, essentially? So this might seem a little confusing, right? Because how can we figure out which one is going to be a little bit better to buy? So let's think about some numbers, right? So if I took the 23,437.5, and I divide it by my my standard tank of 12,000, right? In your calculator, this is going to give you about 1.9. So what this tells me is that you are getting almost double in the jumbo than you are in the standard, and you're only spending 50% more. That does not mean twice as much, right? So let's throw some numbers to see if we actually agree with that. So let's take a look at our jumbo versus standard. Okay, so something that's really easy is if I just make my standard $100. So each standard oil tank is going to cost $100. So that means 50% of 100 is $50. So that means the jumbo tank is going to cost 150. Okay, so let's pick an arbitrary number. Let's say that we are wanting something to hold, 375,000 gallons, right? So for the jumbo, if I take that number and I divide it by 23,437.5, so if I do that in my calculator really fast, I am going to get a grand total of 16 jumbo storage tanks, right? So I'm going to do the same thing over here. I'm going to take the 3,000 or 375,000 and I'm going to divide it by 12,000, right? And again, I'm going to do this in my calculator. And this is going to be 31.25 storage, the standard. All right. So if I multiply the 16 by 150, right? So if I take 16 jumbo tanks, multiply by 150 each, I am about to spend $2,400, right? Seems like a lot of money. So if I multiply the 31.25 tanks, now again, I know you're not going to buy a quarter of a tank, you're going to buy a whole tank. But again, for our sake of our argument, we're going to pretend that you can actually buy just a quarter of the tank. You are going to spend $3,125. Now, which one is going to be more expensive in the long run, right? The standard. So what do we actually want to go with? We want to go with the jumbo, right? So that's kind of the mathematical proof of why part B, which one's better to buy. We're going to say the jumbo. Okay. So part D and part C, really what they're doing and asking us to do is kind of just a little conversion. So they're telling us if 1 cubic foot is approximately 7.48 gallons, what is the volume of the standard model, right? Now remember, volume has to do with cubic, so we want to make sure that we stay in cubic, so that's perfect. So what do I know about standard volume? I know that it's 12,000 gallons, right? And I want to convert that, so I'll put it over 1. So I want to convert that to cubic feet. So that means, let's read this, 1 cubic foot. So the cubic foot is going to go up on top, so I'll put it like that. And for every cubic foot, there is 7.48 gallons. Well, notice that I got gallons on the top, gallons on the bottom. So if I take in my calculator 12,000 and divide it by 7.48, I should get about 1,604.7 feet cubed. All right. Now, what happens if I actually want to change my my feet to meters, right? So how many cubic meters of oil does the standard model hold? Well, I'm going to take this information that I'm given. So 1604.17 cubic feet. Now, I'm told that 1 meter is about 3.28 feet. This foot does not have a cube with it, right? So I actually have to cube both the meter and the foot. So I'm going to put the cube there. So in reality, 1 cubed just stays as 1. 3 cubed is really 27. So bring this down just a bit. So 16.0, oops, not 16 point, just 1604.17. If I divide that by 27, you are going to get roughly 45.46 cubic meters. So that's how many meters are in one standard tank. So when it talks about E, what is different about the calculations in part D compared to part C? How are they related to the scale factors? Well, notice that in part C, did I have to cube anything? No, because I was already given that information in here. Cubic foot to gallons, so I was able just to cross things off, right? Little conversions. But in part D, I had a cubic because it was given to me in what's known as linear units instead of cubic, right? So linear means that your exponent would be a power of 1. So that's basically what E is talking about. All right. So that leads us to our very last question. All right. So our last question is this. So Rosaline is ordering wood chips to cover her dog run area. The size of the dog run is 9.5 feet by 12 feet, and she wants the wood chips to be 4 inches deep. Right? The wood chips are sold by the cubic yard at the landscaping supply store. So let's go ahead and copy or underline some important information. So 9.5 by 12 feet. So I'm assuming, right, that's going to be something like this. So 9.5 by 12 feet. Okay, what else? Ooh, it wants to be 4 inches deep. So we got to remember that. So we might have to do a little bit of conversions later. So the wood chips are sold by the cubic yard at the landscaping supply store. So Rosalind calculates that she should order 12 cubic yards of wood chips. But when she calls to place her order, the person at the landscaping supply store tells her that that amount would fill an entire dump truck. So it sounds like she made a mistake. What could we do to help her, right? So we want to check her calculations by doing our own calculations and figure out kind of what went wrong. Okay, so we have to get a much smaller number. So I want you to go ahead and I want you to pause the video and I want you to think about what she probably might have done wrong and how we need to figure out what the correct answer is. So go ahead and pause that video now for me. All right, so again, I'm going to run out a little bit of space. So I'm going to bring in another piece of paper right here. Okay, so I'm going to start off with what I know. So I know that I need to basically find the volume because it's going to be cubic yards. So I know I'm going to be multiplying 9.5 feet, right, over 1 by 12 feet over 1. And I do want to multiply it by my 4 inches, right, my 4 inches over 1. But here's my problem. I got feet times inches. That's not going to work. So what should I do? I should probably convert my inches to feet. So ask yourself how many inches are in 1 foot. And hopefully you said 12. So this might have been where Rosalind made her mistake. Maybe she didn't convert this to inches and she left it as, she didn't convert her inches to feet. Maybe she did leave it as inches. So inches and inches cancel off. So we got feet, which is perfect. And I'm going to go ahead and help you out with this one. For 1 yard, right, it's about 3 feet. Okay. Now I want cubic yards. So that means I need that yard to be cubic. And I need all of my feet to cancel out because I got 3 of them now. So I need to cube that, right? So 9.5 times 12, right, times 4 should be 456, right, feet cubed. We're going to multiply that by 1 yard cubed all over 27 feet cubed. What's going to happen? My feet cubed and my feet cubed are going to cancel each other out. we're going to go ahead and divide 456 by 27. And, oops, not 27. I forgot about the 12. So I should probably multiply that by 12. Can't forget that one. So we're going to multiply 12 by 27 and then divide all of that by 456. And we are going to get about 1.4 yards cubed. 1.4 versus 12 is very different from each other, right? So we probably couldn't order it as 1.4. If we should actually order, I'd probably say it should be about 1.5 cubic yards. If we have to order a whole number, then obviously we're going to go positively. We're going to say 2 cubic yards, essentially. So she's definitely made a mistake. So there's a lot of places that she could have made a mistake. Maybe she didn't convert the 12, so maybe she just divided the 456 just by 27. Maybe she didn't cube the 3, right? So maybe she just left it as 1 yard over 3 feet. Or maybe she didn't even realize that she had to change it to 1 yard was equal to 3 feet, right? So there's a lot of different things that Rosaline could have made a mistake, okay? And as you can tell, right, your methods and meanings box is actually also on this paper. So again, go ahead and take a moment to read that and make some more sense of that.